Okay, for this problem, we've got trapezoid ABCD, where AB and CD are the two parallel sides. We've got the two diagonals drawn for the trapezoid, and E is their point of intersection. And then we're drawing a line PQ through that point of intersection that is parallel to the two sides for the two bases. And we'd like to say, is there a way to find the length of segment PQ, where P and Q are the points of intersection of the two non-parallel sides? The posted problem gives us the distance from A to C is 15, but it turns out you don't need to know that in order to solve this problem. Okay. Now I'm going to share my screen and go to Desmos to convince you that for base A equals 8 and base little b equals 16, the distance from P to Q always be 32/3, regardless of how the rest of the trapezoid is positioned. So let's just try that. Here we are on Wyzant. Here's the trapezoid. And the bases are 8 and 16 right now. And if I rotate around point D, but leave the bases with the same size, the distance from P to E and the distance from E to Q remains 16/3. So the total distance is 32/3. And if I change the lengths of those two sides, two non-parallel sides, everything remains the same. If I change the length of the base, then those values change, but they do remain the same. In this case, 30/7. There's the rotation. Okay. So now the question is, how do you derive the fact that when A is 8, B is 16, we get this 32/3? Okay, so here we go. The first key to recognize is that triangle ABE is similar to this purple triangle, CDE. And the reason is by angle. And that's because when two parallel lines are cut by a transversal, alternate interior angles are congruent. So these angles with one arc mark are congruent, alternate interior angles. The same with the two arc marks. And here at point E, we have vertical angles. So there's a couple different pairs you could use to prove those two triangles are similar. And that means that AB is to CD. There's AB is to CD, as BE is to ED, as AE is to CE. They all have the same ratio, and that ratio happens to be A to B, because we're letting A equal the length of AB, little b equal the base of the length of CD. And so I put a multiplier on here of S. But if you put AS over BS, you get A over B. And the same for the ratio of AE to EC, it reduces to A over B. Okay, so we want to remember that for the next diagram. Here's what that looks like. Now we're going to look at these two triangles on the left, this little one at the top, slightly green, and the big triangle. And they are similar, again, by angle. This time it's corresponding angles instead of alternate interior angles. So BE to BD, well, BE, we remember we said was AS, and ED was BS. But so BE, or BD rather, is AS plus BS. And if you factor out that S in the numerator and denominator, they cancel out. So there's the ratio for the corresponding sides, A over A plus B. In this particular case, that reduces to 1/3, 8 over 24. And now if we multiply both sides by DC, we get the length of segment EQ by multiplying by both sides by DC, but DC is really represented by the letter B. So there's the length of segment EQ, AB over the quantity A plus B. And we're going to get the same thing over here. That means E is always the midpoint of segment PQ. And I won't go through all the details here, but the idea is the same. Use these two triangles over here, the green one and the big blue one. Corresponding sides are in proportion. Remember, this was AT, this was BT. So AE is to the entire AC is this ratio, proportion, or this ratio right here, but you can cancel out the T's, multiply both sides by DC, which is represented by B. And so each of these segments, PE and EQ, is AB over A plus B, regardless of the values of A and B, as long as you're forming a trapezoid. There you go. Hope that helps. If you have any questions, post a comment.